Welcome back, everybody, to another video. We're going to be beginning chapter 4, topic 4 today, and we're going to be going over triangle congruence. How can we tell if triangles are congruent? And more than just triangles, we're going to be focused on congruence in general. Okay, congruence. How do we know that two things are congruent or not? So we're going to go through that. Let's get started. Let's go ahead and scroll down, or not scroll down, turn the page. We're going to go to the warm-up, and we're going to go over our big idea for congruence. Okay? This is our big idea for A. I'm actually going to type it up this time. Okay? So, this is big idea for A. And in general, we're just talking about congruence. Okay? Now, with congruence, you want to be able to do a few things. The first big thing that you need to be able to do for congruence is understand how we determine congruence. And there are two methods to determine congruence. The first is to determine if every part of an object, of two objects, N are congruent in the same order. Now that's a big deal, because you can get objects where parts of them are congruent, but it's in a completely different organizational pattern, and as a result, the objects aren't exactly congruent. Okay, so they need to be in order. This takes a lot of work. We're going to see it in just a little bit. But the second way that we can do it, the advantageous way, is to transform one object to perfectly land on the other. Okay, that's what we're going to want to do. So we want to determine if two objects are congruent, if they have the same order, and we're going to transform one object to perfectly land on the other. Okay, these are two main ways to determine congruence. They can get pretty complicated after you get to more complex shapes. So I just want you to be prepared for that. And let's get to it. So now that we've got our general idea and what we're expected to do for congruence, let's go on over to the beginning of lesson 4.1. Now, this beginning activity you guys will be doing in class, but we're going to get right into example number 1. So, suppose there's a rigid motion that maps one figure to another. Why does that show that the two figures are congruent? So think about this. If we've got rigid motions, why do we know that it makes the shapes congruent? Well, there are two main things with this, and I've been getting used to typing, so I think I'm going to type here too. And there are two big deals with these transformations. Okay? A rigid motion transformation keeps the object the same shape and size. So, a composition of rigid motions will not change the object. Okay, so just doing a whole bunch of rigid motions in order won't change the object, but they allow us to determine if two objects are congruent, because that means they're the same shape and size. Okay, will not change the object. Any transformation will produce, or any rigid motion transformation will produce a congruent object. Okay, and that's really why. If we do these transformations, if we can show that they're true, then that they work, then they produce a congruent object. So a 90-degree rotation about the origin maps PQR to LMN. Are the triangles congruent? Let's take a look. a 90-degree rotation maps PQR to LMN. Are the triangles congruent? The answer here is yes, the triangles are congruent because a rotation does not change the shape or size of an object. Okay? All right. Now, let's take a look at this figure real quick. Let's think about the process in which we were able to show that this figure over here, A, B, C, D, E, F, is congruent to this figure over here, G, H, I, J, K, L. Okay? How can we tell that this figure is congruent to this one? Well, we just did a series of rigid motion transformations, and you can see them here. We reflected across this line, x equals -1, and it produced the object here. Then we translated right 2 and down 5 here. So we're able to show that these objects are congruent by showing that series of transformations. And I want to write that series of transformations down. So we start with a reflection. We do a capital R for reflection. We're not reflecting across the y-axis, but across x equals -1. And we're doing that to A, B, C, D, E, F. And after we rotate, or after we reflect, we're going to translate according to this rule, 2 and -5. Okay, so we reflect and then we translate. And that's going to produce G, H, I, J, K, L. So that input, or those two transformations on that input, produce that output. All right. So let's take a look at this figure and come up with what composition of transformations will get this figure to translate to the other side. Let's start with, I believe, A, B, C, D. And see, how could A, B, C, D transform to Z, X, W, Y? All right. Now, it does say what compositions, but we might be able to get away with just one transformation. Now, the reason that I say that is I'm noticing something. You know how C and Z are the same point on these triangles? So if I want to show that they're congruent, I want to move C to Z. I want to move A to X, and I want to move B to Y. One thing I'm noticing is that the distance from A to X can be cut in half right here. C to Z can be cut in half right there. B to Y can be cut in half right there. That makes this the center of a rotation. We can actually rotate around this figure and transform ABC so it lands on X, Y, Z. And that's what we're going to do. Now, this rotation, rather than having a center at 0, 0, it's going to have a different set of coordinates for its center. In this case, it'll be -0.5, comma, 2. Okay? So we're going to rotate about -0.5, comma, 2. And how far are we going to go? Well, one thing I notice is that this length rotates and goes to here, so it's kind of going the opposite direction. If you remember, that's 180 degrees rotation. Now, since we can choose what direction, since we're going 180 degrees, I'm going to put 180 degrees there. You could still put a -180 degrees if you wanted, but that's what I'll do. So we're going to rotate 180 degrees about that point. And if we do that to ABC, we will get X, Y, Z. And there we go, a series of rigid transformations that will show that these two shapes are congruent. Now, just one last thing to show before we move on, and I just want you to see the transformations themselves. So let's get that highlighter set. Sorry, gotta erase that. Get that highlighter set, and 1, 2, 3. Okay, so I'm gonna take this and I'm gonna transform it using my awesome iPad tools. So I'm gonna rotate it about that origin. And whenever I do, it goes right there. Just one quick rotation. And we've got it. As they say, Bob's your uncle. All right, so we're able to show that these two shapes are congruent by doing one rigid transformation. Now, we could do two rigid transformations if we wanted to. I might take this and reflect it here. So it goes up like this. And then I could reflect it again here. And it goes up like that. And we learned that two reflections could be done to get you the same rotation. Okay? Could have done that. All right. Now go to the try it. Take a look at this one and think, what's a composition of transformations that'll get LM or KLM to land on GHJ? Okay? What's a composition that maps that? Pause this video and see if you can come up with a composition that actually maps these two. Okay? And let's see if you got it. Now, for me, I'm looking at this and I want to do two things. I could do two different things pretty nicely. I'm going to try one that most people go to first. So I'm going to take LMN and I'm going to translate it up here. Translation's a perfectly good one. After I translate it, I notice, there's this line right here. What if I reflect it across this line? Well, if I do, then this diagonal is going to go out here. It's not really going to work out the way that I want. So, reflecting across that line is probably not the best choice. Now, another big reason why is if I look over here, this is our flat length. I want that to go up there. So, maybe not a reflection to get that there. Could I rotate it? The answer is yeah, I can. Let's go ahead and see if I can rotate this. K needs to go to G, L needs to go to H, and M needs to go to J. Now, I notice how all three of those, as I show where they're going, they all meet in one specific place. This is going to be our center of rotation. So if I rotate LMN 180 degrees across that, I'm going to get it to GHJ. Just one simple transformation, 180 degree rotation. Except, again, it's at a different point. So I can rotate 180 degrees about the point, I believe it's 1 comma negative 2. Could be wrong on that, yep. 1 comma negative 2. And I'm going to do it to either GHJ or KLM. And that's going to produce GHJ. All right, so I'm showing one composition that'll work. What's another composition that'll also work? Take a second to see if you can find out another set. All right, let's see if you got it. Now, there are tons of different transformations that you can use. The one that I'm going to use next is, again, a double reflection. So I'm going to take KLM and I'm going to reflect it across, not the y-axis, but across the line y equals negative 2. I'm going to reflect it across this line right here. Okay? And whenever we do, we end up with a figure that looks like this. K doesn't get reflected because it's going to stay in the same spot. That'll be K prime. L does get reflected. Notice how far it is away. 1 unit, 2, 3, 4, 5 south, 5 below, 1, 2, 3, 4, 5 above. So we're going to mark that at 5 above. That's L prime. M is the same distance as L. It's just reflected up here. So this is M prime. And now I've got my new figure. There we go. MLK. All right, now I need to reflect that again. And you'll notice that I can reflect it the 1 unit away from M. Or M prime, I should say. If I reflect it across this line, let me change highlighters here. Reflect it across this line next, then it'll land perfectly. And we can see that because M is 1 unit away, Y is 1 unit away. L is 5 units away, H is 5 units away on the other side. Oh, I actually made one mistake earlier. L should be 1 unit further. So let me go ahead and take that and switch back to that pen. This is L prime. So L reflects to H and K will reflect to G. So I'm going to go ahead and write down this composition of transformations. I took KLM and first I reflected it across the line Y equals -2. After that, we did a second reflection across the line X equals 1. X equals 1 is that yellow highlighted one. So I'm going to highlight that one yellow, and then I'm going to switch to green and highlight this one. Okay? And whenever we do that, that produces GHJ. Notice how our series of transformations can work, and you can come up with lots of different ones that'll work. Now, take a moment to try out example and try it number 3 yourself. What transformations or which triangles are congruent? Is it EFG and ABC? Is it ABC and LKJ? KLJ? Sorry. ABC and JKL? Which one? Which two of these 3 triangles are congruent? Once you figure out which one are congruent, actually complete the transformations that would show that they are. All right. With that said, I'm going to bring this video to a close. I hope you learned a lot. There's lots more to practice here. What transformations would show that these are congruent? But I think we've gone through enough together as a class. Since we did this last chapter, it should be pretty nice for us to work on.